In the previous video, we described the process of converting a data object into an index, which is going to physically map that object into the hash table. So essentially, now we are going to describe the different components that will allow us to generate that index. The first one is hash function, which is what we are going to discuss in this video, and then we'll discuss the reduce function. So essentially, a hash function is a function that converts a data object to a hash code. That's the entire gist of it, which is, let's say if you are given some data object, how do we represent this in the form of an integer? We don't care how big is the integer, it could be really large. And we have already seen a couple of them, which is like, let's say if when we discussed the first way of representing strings, which is taking the first letter, like let's say if you had apple, if it took the first letter and just changed it into 1 or used its ASCII value like 97, essentially it is a function that converts any data object into an integer. Now I want to emphasize here that generating hash functions is really hard, and how do we actually create them? It's beyond the scope of the course, because we saw a couple of them, which is when we discussed the fact, like let's say if you have Unicode values or if you had ASCII values, what we did was for a particular string, we essentially used the powers of 127 to represent, like multiply each characters of that string with powers of 127 to yield an integer, but we were still getting these overflows. So essentially, like overflow errors, or we were still getting collisions. So essentially, generating a good hash function is beyond the scope of the course. It is a topic that is studied actively in both mathematics as well as in sub branches of computer science like cryptography. So like what we are going to discuss is, we are going to discuss what is a good hash function and what is a bad hash function. What we are not going to discuss is how do we actually generate them, because that is like really hard. So for a hash function, these are the 4 properties that are essential for every hash function. It should take in an object X, which could be of any type. It returns an integer representation of X. Like here, integer doesn't mean like the integer of a programming language, like long or integer. I'm not talking about data type, but just like a regular integer. The third property is that if X is equal to Y, then HX should equal to HY. What this means is, like let's say if we have like 5, that is a number that we or like let's say if we have an object that's called car, okay? If we have car that we are storing into this hash table, if passing this car into the hash function yields 5, like a number 5, I'm just using an arbitrary number 5 in the first instance, and next time if I have like another time we pass in car and it returns a 6, that is not a valid hash function, because when X is equal to Y, like here, both cars are like 2 different objects, but essentially they are the same objects. If it did not yield the same values, then it will get really confusing, which is it will be ambiguous as to where that index is. So essentially, it should always yield the same values for two similar values of X and Y. The last property is that if X is not equal to Y, then we anticipate that both HX and HY are not equal to each other, but they can be actually equal to each other, which is if I pass in H of car and let's say if I pass in H of cart, we want that these 2 numbers should be different, which is 5 and 6 is, hopefully it will be different. That's like a characteristic of a good hash function. But if they are equal, which is if they are equal to 5s, like this is car and this is cart this time, then it's perfectly fine. Like that's absolutely allowed. Like we want something, but it's not required. Okay, so let's discuss a few examples of different hash functions. The first one is this one, which is like return 0. Like let's say if we have a hash function x which takes in an input x or a data object x, it returns a 0. So what do you think? Like pause for a second and what do you think about this hash function? So this one, is this a valid hash function? The first thing we are going to discuss. So let's discuss the properties. The first one is object x. Like let's say if we have hx is equal to 0. Now it has it takes in an input which is correct. It returns an output. It's going to always return 0, but that's fine. If hx is equal to y, like let's say if I pass h of like car in this, it's going to return 0. Now if I again use h of car, it will again return 0. So essentially the third property is also satisfied. The fourth one is if x is not equal to y, which is h of car and h of cart, like if we were using these two values, this would return, this hash function would return 0, which is, they are equal, but this is not strictly enforced, which is we want it to be different, but essentially it's returning the same value. So it's an absolutely valid hash function, but it is a really, really bad hash function because no matter what object we pass into this function, it's always going to return a 0, which is there'll be a 100% chance of a collision, like whatever object we throw into this. So it's not a good hash function. The next one was sum of all ASCII values. Like let's say if we pass in a string into this, my intention was x is a string. Like I'm using x as a string specifically for this example, but you can treat of x like any particular value. Like let's say if it is like a file, what we might have is within the hashing function, you might have all the characters of a file and you're using the same function, which is the sum of ASCII values of all the characters in a file. So essentially, like if we had this function, like if we had ABC passed into this function, what it would do is it would just sum up the values 97, 98 and 99 and return like a value. So this is again a perfectly valid hash function. Like I'm not going through the properties again, but you can like test it out. But the issue here is that, is it a good one? It's okay, but not the best. Why? Because like let's say if instead of ABC we had CBA, it's going to return the same value. Or instead of ABC, if I add one letter here, which is like, let's say if I add B here, this is B, and I decrease one letter from here, which is BBB, all of these will have the same like output for a particular hash function. So again, like it's predictably, like we can predict this to get a result. And whenever we can do something like this, which is when we predict a certain result for a particular hash function, it is usually like not the best idea. The next one is this one, which is powers of 31, which is earlier we used powers of 27, but you'll see later that actually it's not recommended that like whenever we are doing the powers of a certain number method, we typically would use a prime number. Like powers of 31 is actively used in Java. Like the libraries, the standard libraries actually like the hash function is a certain function that is peculiar to almost all languages. Like it is implemented in some form. So in Java, like if you get a hash of a particular object, like if you see the object class in Java, that has a compulsory, like mandatory implementation for a hash of that object. So behind the scenes, what it's doing is it's computing the powers of 31. It's using the powers of 31 method to generate a hash code. So essentially, if you use this method, this is a good hash function. And why? Because like whenever we use prime numbers, like 31 is a prime number, you would have like when you study like more details in number theory, you will see like if this is not a prime number, certain objects would resonate after certain intervals. So it's usually required that you use a prime number rather than like a number that is a composite number or divisible by another number, which actually yields like overflow. Like if you have overflows, you would see similar strings occurring at the same particular index. Like if you have like a long, very long string, and that ends in the end with University of Florida, what you'll see is if you use like mod 27, what it's going to return is it will always return these last characters, like whatever string it has, it will always return University of Florida, the strings that end with University of Florida at an index 5 if we use like a normal composite number. But if we use prime, that is avoidable. It's not like, we are not going to discuss why that happens, but that's the gist of it. You have to use like a prime number rather than a composite one. Now the last two functions, which is if we have a value that we pass into this function, we return a random number. This is an invalid hash function. Why? Because like, let's say if I do a hash of cat, it returns me like a random number like 7. And if I do a hash of cat again, it might return some other random number. So it's not satisfying this property, the third one. So essentially it's like invalid. And the last one is h of x equal to return current time. It is also, again, like although this is predictable, it's still not returning the correct value, which is like, again, hash of cat would return the current time right now. If I do again hash of cat, it would return some other current time. Like it's returning the correct output, which is like it's returning an integer, but it's the for a similar input, it's not returning the correct output. So these two are invalid. Okay, so as I discussed, this is a good one. But there could be a lot of different hash functions, and it is your job as a programmer to typically implement these hash functions for the different classes you build. Okay, so I'm going to end this video with a discussion on like what is usually a good hash function, which is hash function should follow like two properties, which is the first one is it should evenly distribute the data, which is like, let's say if we have 10 buckets in our table, we don't want our hash function to compute index such that like if we have completely random objects, it is favoring objects to store in the first half rather than the second half. We want it to evenly spread out the data. And the second one is it should be easily able to compute, because remember, like when we are converting some data object into an index, that has a cost associated with it. And if that cost is a lot, it will defy the entire purpose of getting like a constant time access. Because let's say if that takes in like n times, like let's say if you have n representing the number of data and somehow you create this really weird or awfully slow hash function, then there's no point of actually using a hash table itself, because we want like fast lookup and fast insertions. Another thing, as I described, like primes should always be used, and smaller primes are used because we prefer faster calculations. So although we saw here we had ASCII characters, we know that it's going to guarantee we are going to have a collision no matter what. So instead of using the next prime number after 127, we are using just the next prime number after 31, after like some arbitrarily small number, which is 31, because it's computationally like cheaper compared to 127. Because if we do like 127 to the power like 100, like it will take a lot of time, but 31 might take like less time, and so on. So that's the gist of it. In the next video, we are going to describe like we saw the first section of our process, which is we saw what is a hash function and how we can use that. And now we are going to see the reduce function as well as the collision resolution strategies in the next one. Thank you.